trial probabilities. Now, there are different types of Bernoulli trial situations. Now, we've already calculated the idea of some of Bernoulli trials. If you've forgotten, Bernoulli stands for by outcomes, which means we either have something that's we define as a success that we're looking for and something that is a failure. We define the probability of a success. We can use P of S, but you might also just see the letter P. And we have the probability of a failure. You might see that as the probability of F. You might see that as, that's a P right there. You might see that as, it's the same thing as 1 minus P. And you actually, we might even use Q. All right, so the probability of a success is P, and therefore the probability of not getting that would be 1 minus P. We're going to focus on, the major one that we're going to be focusing on today are problems with probability that are referred to as a geometric distributions. Geometric distributions are a specific type of Bernoulli trials. And we refer to geometric as the probability of first success. And you've seen these type of problems already. So I've already given them to you where I said, hey, I gave you some type of probabilities, and I said, what's the chance, or what's the probability that the first male was the 5th student? The first male selected was the 5th student. And then, of course, you were like, oh, that means the first 4 were not males, they were females. So it's not a female, or not a male, not a male, not a male, not a male, and then times the probability of a male. That's the idea that we're going to be doing right here. But we have some specific notations that we can use. So what we say that we can say X follows a geometric distribution would P equal with P probability. All right, so this says X follows a geometric distribution with probability of success equal to P. And of course, that number is going to change depending on the problem. So if X follows a geometric distribution, then when I say the probability that X equals K, this stands for the probability that the first success happens on the K trial. On the Kth trial. Okay? And I know there's a lot right here. So, and I'm going to put in numbers right here. So the probability that X equals K is equal to, well, that means the first ones are failures. So that means what's going to happen is it's going to be a failure. How many failures would we have? Can anybody think about that? For example, if I told you the first success happens on the 10th try, okay, the first success happens on the 10th try, how many failures happened? Before? 9. Perfect. Yes, 9. How did you get that?
Because you said the first success was the 10th. Oh, all the other ones had to be failures.
How did you calculate that?
I didn't really calculate, I just thought about it.
You did calculate it. Well, you did a calculation. It's a very simple calculation. What did you do? Anybody want to chime in? How did she get 9? If I told you that there was 10, the first success happens at the 10th trial. Like what? There we go. 10 minus 1. So, and if this happens on the kth one, then it's k minus 1 times p. This is basically the formula for first success. Now, you don't have to memorize it as being geometric, but the first success probability is always going to be failures, k minus 1 times the probability of success. So for example, and I'll just be, just kind of give it to you. P equals 0.2. And there'll be some context around the problem. But then the question is, what is the probability that the first success, and in your homework it might say something like the first time you find a person with type AB blood or something like that, is on the, let's go 6th trial. Okay. Now, you could remember that this is geometric and there's shortcuts around doing it. But I want you, for the most part, what I want you to do is utilize the notation. So we're trying to say that here, so x equals first success. And so we're trying to find the probability that x equals 6. That the first success happens on the 6th try. Which means that we get what? How do I calculate this? How many failures did I get? Or what's the probability of a failure? How many times am I not going to get a success if the first one happens on the 6th try? 5. So it's going to be to the power of 5. Now, what is going to be raised to the power of 5? Well, it's the probability of not getting a success. So what's the probability of failure? What is Q? It's 1 minus 0.2, which is
0.8.
0.8. So it's 0.8 to the 5th power times 0.2. 0.8 to the 5th power times 0.2. That's it. That's all you got to do, the first success. Probably a first success is 0.8 to the 5th power times 0.2. What does that give me, though? Can anybody put that into their calculator? And someone's saying 0.06. So 0.8 raised, to the 5th power times 0.2. 0.0, we'll go at closer to 0.07. 0.06 is not going to be that bad, but he should be rounding at least correctly. And so we get 0.0, 0.0, the first 0, so 0.6, and then the next one gets rounded to a 6. Would we accept 0.6? Most likely. 0.7, yeah. Oh, 0, sorry, 0. Right there. And there's my answer. Now remember, show work. So those are going to be the basic problems that you're going to do. All right. Now, as a review, so let me count that as question A. B, just as a review question, what is the probability that I get at least one success in 6 trials? At least one. Okay, now this one's a little bit different, okay, because we can actually say, we could say, okay, what I can say it's the probability that I get it on the first one, the second one, the third one, the fourth one, the fifth one. That is an actual way of doing it, and I'm going to show you that right now. So there's a long way, all right? There is technically a long way. I'm going to show you that very briefly. Hold on real quick. Well, let me give people the time to write this down. So if we we could do this as this is equal to the probability I get it on my first success plus the probability it happens on my second plus the probability the first one happens on my third plus the probability it happens on my fourth. Oops. Well, actually, no, this is off because then I'm missing a lot of different ones. Never mind. Don't ignore that part. I don't even want to do that. Basically, this is a review topic. This is a review. Whenever you get this at least once, that means it's basically 1 minus the probability that it doesn't happen. This will pop up in your homework. No successes. All right. So it'd be 1 minus. How many times will I get a failure? If you have no successes, how many times will I get a fail? Sorry. So it's 0.8 because that's a failure. Failure. Probability of a failure. And how many failures would I have? If I do it 6 times and I get no successes. So how many failures happened?
6.
6. So I raised to the power of 6. And then technically there's 0 successes, so you don't have that times anything right there. And then this is the answer. Can someone calculate that and see what I get? This is just a review of the at least one success problem. You'll get that in your homework tonight. It kind of pops up all over the place, so I do want to make sure it's covered. So what do I get? Probability 1 minus 0.8 to the 6th power. 1 minus 0.8 to the 6th power, 0.74. There we go. Now, the other question that they will give you that we want to know is that in a geometric distribution, it is a distribution. Which means it has a mean and it has a standard deviation. Now, the mean one is the one that's going to happen a lot more. And so we actually refer to this as the expected value of x and the standard deviation of x. All right. And so the expected, which is really, once again, the mean, first success is a simple probability question, is a simple answer. The expected value of a first success is simply equal to 1 over p. So we say that the mean is equal to 1 over p. That's a big formula. This is important. You're going to get this question a lot. The other one doesn't happen a lot, but it also has a standard deviation. And the standard deviation is the square root of 1 minus p over p. I don't believe I asked you any questions on your homework with this one right here, but these are the means and standard deviations for geometric first success. So what it tells you is it tells you expected. So for example, here's a real world context type question. Well, I'm going to put it in terms of real world. So the example, the probability of randomly selecting a student that owns a car. I don't know, we're just breaking something. That owns a car is 0.08. So let's say 8% of students own a car. I know that's probably a little too much. Maybe I'm wrong. Maybe it's too little. How many students would I expect to select before finding the first student with a car? What standard deviation? So it sounds like a hard problem, but it's actually very simple, especially with the mean. To find the expected value of first success, it's simply the formula 1 over p. And so it's 1 divided by 1 divided by
0.08.
0.08, which gives me, what is that? I know what it is. What is that?
12.5.
12.5? 12.5 what? 12.5 what? $12.5 what? What are the units? Students.
Student.
Yes. Now, this throws a lot of people off, right? And just as a reminder, no, that's the mean. Can you select 12.5 students? Yes or no? No. Yeah, guys, yeah, no. You cannot select 12.5 students, but remember, it's an expected, it's an average. So it says that sometimes it's going to be more than 12.5 and sometimes it's going to be less than 12.5, but it's going to be around 12.5. Yeah, so it's 12 or 13. Now, you might select your first student. I might randomly select a student, and the very first student, boom, they own a car. It might happen on the first one. Might happen on the second, third, fourth. Most likely, it's going to happen around 12.5. So the most likely scenarios was going to be 12 and 13. But on average, if we did this every single day of the school year, all right, every single day I randomly select students until I find a student with a car, and I counted how many students it took. If I did that and calculated all those numbers and kept all those numbers, and then I found the average of those numbers, it would be very close to 12.5. So when we say 12.5, the answer is 12.5. It's expected. We expect on average 12.5 students. Now to find the standard deviation, we just have to use that formula. And I know it's an ugly formula in there. You'll be given to it on a formula sheet, but it's the square root of 1 minus p over p squared. I don't even ever really remember it, which is the square root of 0.8, no, 0.92 over 0.08 squared. Okay. You just plug it into the formula. So clear. So square root of 0.92 divided by 0.08 squared. And hold on. Okay. Is that what other people got? Trying to look in terms of. Yeah, that is the answer. It was just a weird answer. Oh, I just forgot to write it down. 11.99 students. Basically, there's a lot of variability. There's a lot of variability. It might happen on my first student. It doesn't follow a normal model. Basically, it's there's a lot to get to. Let me try to do something real quick differently. Just want to make sure. Square root of 1 minus 0.08 divided by 0.08. Yeah, same answer. There's a lot of variability, and it's not normally distributed. And we can see that this is not normally distributed based on the fact that one standard deviation almost gets you to 0. And the minimum you would have to select is 1. So even if we do it just one time, it doesn't happen. 0.08 is a kind of pretty likelihood scenario, and selecting 12.5 is not enough. So that's what the answer is, but this is rarely, I just want to point out that this is rarely, if ever, on AP exam. This was always on the AP exam. They will always ask you about the mean. They rarely do ask you about the standard deviation of this one right here. Okay. So I wanted to keep things nice and simple for you in terms of doing this. All right.